Hey guys, so this morning I woke up, rolled over, looked at my phone as you do, checked a couple of emails, and then realised I've got no Wi-Fi. Where's that gone? So I thought maybe the power was out. Turned on the light. No, that's all good. So wandered out and found my router here is dead. And it's a Cisco small business router, SRP527W model. Very good little router. It wasn't the official power supply running it. This thing reckons it needs 12 volts at 1.6 amps. I only had a 12 volt 1 amp supply on there. So I don't know what's happened. I don't know if the router has failed and taken out the power supply, or if the power supply has failed and taken out the router. Now I won't lie to you, I was in a frenzy and I just wanted to get it working again, so I've already pulled the lid off and had a look inside, and what I'll do is I'll show you what I've found thus far. I haven't yet found the cause of the fault, but I have tested the power supply and it doesn't perform under load very well. So that's what I'm wondering. It's either one or the other's gone and taken the other with it. And at the moment, when you switch it on, it tries to draw basically as much as it can. So yeah, something's not happy internally there. So I'll show you the guts of it and what I've found so far. And hopefully you can see me fix it completely. And here's the guts of it. One large board, a little radio card plugged in for the Wi-Fi, and it is a DSL modem. So you've got your phone line input down this side here. It has a 2-port ATA built in and a 4-port networking. Yeah, 4-port network connections. USB on the side, I think for sharing files over the network with any device. Yeah, so as I said, when it turns on, it's drawing a lot of power from the source, and there's not a low resistance on there at the input end, but obviously when something starts to work, it really loads it up. And so far I've found that I've got 8 ohms to ground on this rail. I don't really know what it's supposed to be as far as the voltage goes. And then what I did was I attached a couple of wires to that cap and slowly cranked up the power on it to see if I could see if anything was getting hot. And it was only around about a volt, and it was half an amp going through it. And the only thing that was getting warm I found was this diode down in here, and that feeds these caps here, and if you measure the end of that, there's 0 ohms to ground, which is not ideal. So next step is to find out, well, first of all, what I'm going to do is I've got the power going back in the jack there, and I'll put some power on there and see if it comes through to this point here. Because I'm pretty sure this is where the problem's going to be, and I mean that 8 ohms might be okay if it's quite a low voltage rail anyway, but certainly down here we shouldn't have a dead short. So we'll carry on down this line here. I'll stick some power into the main socket there, and I'll see what's coming out at this end, if it flows through somehow through a switch of some sort, maybe another transistor, because this diode comes off here, and even though that's quite a small cap, and it looks like switching circuit there is an inductor, it's odd that would feed through to here when these caps are so much larger. They're 25 volts rated. So okay, let's turn that on and see what's coming through there. Okay, now I was going to measure off the end of this diode here, and nothing will happen until I switch this unit on, and there's actually a an on-off switch which connects a couple of pins to turn the thing on. I've got it set to very low current at the moment. So it's now 50 milliamps. I'm just going to wind that up slowly. 120 milliamps, 200 milliamps, 300 milliamps, and we're only getting 100 millivolts there, and it's not getting hot. In fact, nothing's getting hot actually. Okay, I'll just wind that up a bit more. There's half an amp flowing there at the moment. Still nothing getting warm, not even that diode there yet. It's interesting that that's how that's going. Let's look at this at another angle. Okay, I've just had a closer look at the printing on the board, and it does actually have voltages. There's a test point right there for 1.8 volts. There's one down there for 12 volts. There'll be another one further back for these other inductors here. I'd imagine they're 3.3 volts. And what else have we got? Not jumping out at me the other ones, but that's a good start. So if manually powering sections, you don't want to over voltage them. These ICs on here, some of them will run at obviously 1.8 or 3.3, so if you go too far you blow your chips and then you're done for, and yeah, you won't know it till it's too late. But there's obviously a short on the 12 volt rail that feeds down the bottom here, and if there's another test point down there, it might tell us what that switching supply gives us. 5 volts, there we are. And I would say almost certainly that that's for the USB, 5 volt USB, possibly 5 volts on the wireless card, although that could also be 1.8 or 3.3. But that also goes off the side here and to this switching circuit, and that is putting out 3.3, and this one's putting out 1.2. So it could be either of those three switching circuits that run off the main 12 volt feed in here, off these that have the short on them. So this is going to be fun. Two options. One, apply power directly to there, and very slowly, but at least we know we can go up to 12 volts and find out what's getting hot. And these switching ICs will shut down and they won't switch if there's overload on there. So it may be on the primary side. I don't think it's switching enough to. Well, I mean, it's not a short on the output, so to speak. It's not going to be apparent until it starts working. It's apparent before it starts working, and yeah. So I'll start with that. I'll put a bit of power directly on here because it wasn't getting all of it's from, I mean, yeah, I don't know why that had, unless that normally has, no, it's a 10 volt cap, that wouldn't normally have 12 volts on it. So we'll power directly off here instead of going from there through that diode, and see what we can achieve. I don't want to let the smoke out. I mean, it might be that obvious, but we'll try and do it non-destructively. Just ease the current up and see what happens. Okay, so I've soldered a couple of wires under there, and it's to that cap. They're all connected together, and just at the moment it's just passing 120 milliamps. I don't like this connection though. It's a bit loose. Keeps dropping off. Anyway, and I'm just waiting to see what warms up, and so far nothing. It's 130 milliamps, and I'd be expecting something soon to be showing signs of power dissipation, especially as a dead short. So just sometimes you feel it more through the bottom of the board than trying to get your fingers down in the gaps between components and on components and whatnot. I mean, the board is going to be a really big heat sink, and it's going to draw away a lot of what's going on, so we may need a little bit more than a couple hundred milliamps. Let's wind it up a little bit. Here's 300 milliamps, and still nothing. I've never seen a shorted capacitor, but I suppose it could happen. not an electrolytic, if they were getting hot, but no, that would be funny. No. Check our main switching ICs, and they're not showing any signs of dissipation at all. What a mystery. This is where a thermal imaging camera would be really handy. Perhaps I need to wind the wick up on the power supply a bit more. One thing I've seen, it's quite a couple of times, is that ceramics, surface mount ceramics there, they can alter their resistance once they start to go low resistance. It goes all over the place when you start passing current through them, and they get hot, and at one moment you think you got a short, and then it's gone, and then it starts to come back, and then it's not quite a short, and yeah, still nothing. Let's knock it up a bit more. At one point I had 1.5 amps going through from the main power socket before I decided that something was terribly wrong. Even though it says that it needs a rated 1.5 amp supply. It shouldn't be drawing that much, even really. I mean, they'd want to over spec it a little, I'd imagine, just for reliability. Wow, I'm really getting nothing. That could be one of the tiniest components. If it's one of these tiny little midget bloody 0.5 millimeter capacitors, you'd struggle to feel the heat off that, because the board would be sucking it away as fast as it could make it. I'm looking on the input side of things to these switching regulators, and something at 1/2 amp, something will have to, I know the voltage is really low. P equals VI, 0 times half. 0 watts. This could take a while. No, not quite. Out of curiosity, I'm just going to measure the voltage on that because my power supply is not telling me anything. I'm getting about 80 millivolts. 80 millivolts across a short to give us 1/2 amp. I may just have to wind this up and just let it go bananas. Let the power supply just feed it everything. I mean, at this rate it's going to take, even if I want 1 watt, it's going to take quite a bit, or even 1/2 a watt, or even if I get 1/4 of a watt, that would be enough to create some noticeable heat. I'm going to tweak this a bit more, and I'll be right back. It's funny how you can put your hand on something or put your finger on something and think you can feel heat, but your fingers are cold. Mine are. It's a bit cool in here, and the slightest warmth feels like something, or any difference in temperature feels like something. But I think I can almost say for certain that down here, this surface mount capacitor here, or this transistor, that looks like there's maybe an inductor beside it and a couple of other resistors and a capacitor. It feels like there could be, if any heat is happening, it's happening around that area there. Currently 0.7 of a volt, so 700 millivolts at 1.7 amps, and if there's anything happening, it's right there. And that's the beauty about using a current limited power supply. I used a non-current limited power supply once, and it was the short was one of these capacitors as well, and different. It was in a television, and of course its resistance characteristics changed as it got hotter, and so it got to an avalanche point where it just took off, and yeah, it got stinking hot. But at least this will maintain it at the current I set it at, and even if it does change, but I was measuring a dead short anyway, so I'm fairly confident that that's where it is, and that's probably that capacitor shorted. Strangely enough, I see it. I've seen it more often than I thought I would in electronics. Those things shorting out. So I'll just run it for a bit longer, and then we'll probably suck it off the board and see if that's our problem. Okay, I'm gonna suck it off and see. The easiest way I find with these, unless they get too large, you can pretty much get your iron tip right across them and heat both sides at once. So I'm just going to put a little bit of solder on here initially, just to get it wet, and the old tweezers, and very invaluable, these tweezers, in dealing with small components. I'll just come in that side. Might need a bit more heat. I'd bet your bottom dollar the grounded side of that cap is sucking all my heat away. Sorry, I can't really get a better view than this. This is shocking. I don't have a decent zoom, unfortunately, and I don't know anything about cameras, so I don't quite know what I need to get a better zoom. Well, I mean a zoom lens, but one that will actually focus close in. This will zoom 10 times, I think it is, but sorry, 12 times, but it doesn't focus. Here we go again. Another way to do this is with a hot air gun, of course, which I may resort to because that'll get some warmth into the rest of the board. Yes. Just try a little bit more solder on that and just crank up the iron a little bit more. Here it goes. Stuck to the iron. That's one way to do it. Okay. Now that that's off, let's see if our low resistance is still there. Just make sure those pads aren't joined together. Easy. Right. Okay, so I now have a reading of 1k ohm and climbing, and if we chuck that on there, measure that and see if that's our shorted component. There we go, 0 ohms. How about that? With a current controlled power supply and a little bit of patience, just crank the power in and find out what gets hot. I don't know what could have caused that to happen. It may have been the power supply failing, taking that with it. I mean, it's kind of silly, really. What are they? Real crap quality components. Any horrible ripple that's coming in from the outside wall plug would be, I mean, absorbed by those large tanks, I would have thought. Yeah. So, now let's see if I can find something that'll fill the gap. Honestly, don't know what value it would be, and they never have any markings on them, being so damn small. But yeah, well, I'll find something of a similar size. I mean, I don't think it's going to be doing a great deal. I'll find out where the other end of it connected to, but yeah, poke something in there and I'm sure it'll work. So here I've got an old Linksys ATA. It's dead. I've got a couple of these and they're just shot beyond repair, but they make great sources of spare parts, and I kind of go the rule of thumb that if a capacitor of that sort of nature is about the same size, it's probably in a ballpark of the right value. But I don't believe it's in a critical area of the circuit. I've had a look at the traces and I honestly can't say where it actually goes, so what it does. So it's probably just there as just another one to throw in, as they do. Yeah, I'm sure while its task is probably important, it might have something to do with it's got a button on top there, and it might have something to do with the D-bounce on the button or something stupid, I don't know. But anyway, I found that little one, and I've pulled it off this board. I will have a look and see what capacitance the meter says it is, just out of curiosity. Ooh, these bloody things get away on you like that. I've even cleaned the ends off so they're relatively flat. Come on, there you go. And I've got a reading of about 4.8 microfarads. Yeah, 4.8 microfarads. Whatever, I'm sure it'll work. So, grab that and grab the tweezers. Put a little bit of solder on the ends of the just a teeny weeny little bit on the ends of the cap. That end and on that end, and pop that into place. Now I've also cleaned off the board so that it sits flat against the board. It's not too critical really. And then just make sure the other one, get that on. I might usually poke a little bit more solder in there just to help it. My iron is very fat tip, that one. The heat in the board, come on. Makes funny noises. Okay, and I will check each end of it just to make sure that one end goes to ground and one end goes to the positive rail, as we know it does. So here's our positive, and I can't remember which one's which. Here we are, positive, and I'm touching the cap, not the board, because I want to make sure the solder joint went right through to the board. So you just the end of the cap. That's ground, and that's that. So we will shut up. We will put our remove our wires that I've put on the bottom. And just a little touch up. I just suck some of that excess solder off actually, because I know there's solder maskers on there. It's not going to be an issue, but you know, you may as well do things nice and pretty like, huh? Make it look half decent. Especially if it has to go back under RMA. Yes, I believe it could have been an option, but I was given the go-ahead to attempt the repair anyway. So, let's see what happens when we power it up. Okay, moment of truth. I'm just going to short out the on-off switch connections. You may notice that I have removed the wireless card. Now, for those who don't know much about wireless networking and radio circuitry, the transmitter circuits do not like having no load or no antenna connected. I could plug it in, but I'm not going to bother. I mean, it's either going to light up or it's not. Having the card in is not going to make any difference. But if you power up a radio card with no antenna connected, chances are you'll fry the output transmitting circuit, and I have seen it happen. It doesn't take long at all, and yeah, it's not too flash. So just something to keep in mind if you do need to power up a wireless router or device in pieces. Make sure that the antenna is connected, or if you can, remove the wireless card, like in this case. Okay, I've limited it to just over an amp, and let's switch on. Oh, look at the lights. Now, I don't know if that's a good thing or not. No, I think that is okay. Oh, maybe not. To be honest, I can't remember how this unit behaves when you first turn it on, or how it's supposed to behave. I have seen that happen once before. Knowing my luck, it's going to go, oh, where's my wireless card? I'm not going to boot. Yeah. Okay, I'll plug the card back in. I'm pretty sure that light is supposed to stay solid Yeah, I'll plug the card in, I'll connect the antenna, we might as well do the whole thing 100%, and then we know where we stand. Right, antenna's connected. Obviously we're not going to get any lights up for LAN or anything. I've got nothing plugged into this thing. I just imagine the thing would stop flashing and just go solid once it's booted. You know what I should use? Oh, I should use the proper on-off switch, but I could use a jumper. I wonder if I can make that reach. Oh, here we go. I'll just drag it out the side there. Right, here we are. On. Now I can't tell you what that light does, because the front is facing away from me with all the light connections. I should. Oh, that's good, I guess. Oh, that could be the DSL light. Yeah. Perhaps I should check our voltage rails, since I know where to look for them. Oh, no, I don't need to check our voltage rails. I've got a solid light. Well, I'm going to say that's working. Yes, that's good. I need to get a cable over here and see if I can connect to it. Let's throw it back in the box and just call this done, shall we? It's going to make our life a whole lot easier. Alrighty, she's back in position where it lives. I've got the cables plugged in, it's booting. It's drawing 650 milliamps off my bench supply, because I don't think I want to plug in the wall wart that I was using before when it died. Now, as you can see, we've got power light on the left. We've got LAN ports 1 and 4. Wireless on the right is the other one that's popped up. And I've got my phone on, just waiting to see if when the wireless network becomes available. And oh yes, I've got LAN at least, and we can load Google, we can load TV Guide, yay! All important things. Wireless is just connected. Bloody sweet. Well, that's repaired. Thoughts on this? Well, I guess obviously, well, I don't know what to think. The power supply is not happy. I stuck it on the scope and stuck a load on it, and it kind of went to shit. And so it's entirely possible that, well, yeah, that the power supply failed and caused damage to the router. It does sound strange, like I said before, but certainly in this case, once you have got the device working off a known good power supply, like your bench supply, and I hope you've all got a fairly decent bench supply, then yeah, it would pay to perhaps purchase a new wall wart, unless you feel comfortable cracking it open and attempting repair on that. Possibly using an underrated one. Let's give it some tests. I'll just do a speed test on here on the PC, and I'll also run one on my phone so that it's stressed, I guess, and it's using wireless and network as fast as it possibly can. Well, it's not 100 megabit, but you know, near enough. And begin test, and I'm pulling. Well, it's only gone up to about 700 milliamps, which is interesting, and it reckons it should have a device rated at 1.6. Obviously, the USB stick's gonna use a little bit when you plug one of those in. Maybe we've got a phone call going at the same time, all that sort of thing. Would probably up that, I'd imagine, especially during ringing, when it has to generate ring voltage. It may draw a bit more current then as well, but at only 700 milliamps, then it's pretty much, it's only been using 3/4 of what that power supply was rated at, so I don't know why that supply's failed then. Yeah, it's a bit of a mystery. Well, thank you for watching. I hope this has been helpful and helps you to fault find your products. It doesn't have to be a router, it could be anything that's not functioning correctly, where you've got a short on the voltage rail, or you identify a short anywhere else. It's generally on voltage rails though. I mean, yeah, that's the heart of everything. Yeah, thanks for watching.